Hello to the Reigate College Maths video on loss of kinetic energy in collisions. This is part of the further maths mechanics work. So as we've seen, we've got that E, our coefficient of restitution, is separation over approach, and what we're looking at is the amount of kinetic energy that's lost in a collision. If E is equal to 1, we would say something was perfectly elastic and there's no loss of kinetic energy. However, most of the time E is less than 1 and kinetic energy is converted into heat or sound energy. So when two particles collide, they might compress, and that might generate heat, and then they might expand again. So this situation here, we've got two particles A and B, masses 300 and 500 grams, so we've changed that to kilograms, and they're moving in opposite directions towards each other with speeds 3 and 2. We've got to find the velocities after collision when E is equal to 0.6. So E equals 0.6. Quite a lot of decimals going on here. Might make sure that we put that in a box so we're very clear that that's the coefficient of restitution. And we've got to find V1 and V2, and then the loss of kinetic energy. So we start off using the principle of conservation of momentum. Make it clear that that's what you're doing. And writing it underneath here, we've got 3 multiplied by 0.3 minus 2 multiplied by 0.5 is equal to 0.3 V1 plus 0.5 V2. Working this out, this is 0.9, take away 1. So I've got minus 0.1 is 0.3 V1 plus 0.5 V2. And I think I'll multiply all the way through by 10 here. Minus 1 is 3 V1 plus 5 V2. So that's my first equation. I'm then going to use Newton's law of restitution, which says E is separation over approach. So E is 0.6, is separation, which is going to be V2 minus V1, over, and the approach speed here is 5. So multiplying up by 5, I get that 3 is equal to V2 minus V1. I'm going to want to combine these two equations, so I'm going to call that equation 1. I'm going to multiply this equation by 3, so that then I can add the two equations easily. So I've got 9 is equal to 3V2 minus 3V1. And combining these two equations, I get that 8 is equal to 8V2. So V2 is equal to 1. And if V2 is equal to 1, then V1 must be equal to minus 2. Just substituting that in there to double check we've got that right. V1 is minus 2, 1, take away minus 2 is 3. Yes, and that's correct. So after the collision, V2 carries on with the speed of 1, so its direction of motion is reversed, and V1 goes back this way with a speed of 2, so its direction of motion is reversed as well. Part B says find the loss of kinetic energy. Well, what we're going to do is we're going to work out the kinetic energy beforehand. So K before, which is a half multiplied by M, which is 0.3, multiplied by 3 squared, plus a half multiplied by 0.5 multiplied by 2 squared. So that's the kinetic energy before. Take away the kinetic energy afterwards, or final, because it's lost kinetic energy, and that's going to be a half multiplied by 0.3 multiplied by, now make sure we get the right velocity with the right particle. So V1 is minus 2, so it's going to be minus 2 squared. Just put 2 squared, it's the speed squared, plus a half times 0.5 multiplied by 1 squared. And when I work these out in my calculator and subtract them, I get 1.5 joules. So 1.5 joules of energy is lost in this collision. Second question involves a cannon being fired. And we've got a shell coming out of the gun with a mass of 12 kilograms and a speed of 200. Find the velocity of the gun after the shell has been fired. We need to draw a diagram here. So this is the situation before. The gun has a mass of 600 and the shell has a mass of 12. And both of these are at rest. After the gun is fired, the 12 kilogram mass goes off with a speed of 200. Now we know that the gun is going to go back this way, so we can mark it in as being V1 in that direction. So we are going to use the principle of conservation of momentum. There's no momentum beforehand because nothing is moving. Is equal to, I'm going to take the positive part first, 12 multiplied by 200. This is going the other direction, so that's minus 600 V1. So when I solve this, I get that 2400 over 600 is equal to V1. So V1 is going to be 4 meters per second. Now, kinetic energy, part B asks for the kinetic energy generated. So initially, there's no kinetic energy because nothing is moving. So in part B, we've got to say what's the kinetic energy generated. It's going to be a half m. Let's do the shell first of all. So that's 12 multiplied by 200 squared plus a half m, 600 multiplied by 4 squared. And when we calculate that, we get 244,800 joules. Where has that energy come from? Well, it's come from the explosion, however that's been generated when the gun mechanism has been fired. So that would be chemical and some sort of mechanical energy, possibly electrical energy, has been converted into the kinetic energy of the gun when it's fired. So this question doesn't involve E at all.